Hello everyone, this is Shruti Saxena Das, and in today's video we are going to discuss about lossy compression. It is one of the method for data compression, and in this case the techniques which are used eliminates specific information. In the previous video we have discussed about lossless compression techniques, in which we discussed that we majorly focuses on creating the exact replica. That means that data should not be lost. But in case of lossy compression methods, the data or some information is lost. Here the decompressed data is not same as the original data, but the compressed version is significantly smaller than the original if you'll compare it with your lossless methods. Here we can achieve it by removing the unessential information such as noise or undetectable details. Okay, we can reduce the quality of data in order to achieve the smaller size of the data. You can either reduce the size of audio, video. This method basically focuses on these things. Like lossless method focuses on reducing the size of the text data, but here we focuses on compressing videos, audios or images. Okay, so you can see the methods which are used are JPG, MPG and audio compression. So we are having some extension, like for JPG it is used for compressing graphics and pictures, and the extension which is used is .jpg. MPG method is used for reducing video, for performing video compression, and the extension which is used is .mp4. For audio, the extension which is used is .mp3. Okay, so we'll start with the methods. Suppose we want to compress the text. In the previous video we have discussed that lossless focuses on reducing the size of text data. Okay, the common data which is compressed in case of lossless is text, but here also we can reduce the text, but reduce the size of the text, but in the lossy manner. How? Suppose, see, we are discussing about text. Suppose the text which we want to send is, can you read this? Okay, so what we can do, one method we can use, that we can remove vowels from this. Now if you'll remove the vowels from this particular statement, how we can represent it? We can represent it like this: read this, right? So if you'll get this statement, then also many of you must be able to recognize, or you might be able to read out this thing. Okay, can you read this? Okay, some of you might be reading it, can I read this, right? So some of you might be able to understand it. Now this method can be used, but you can see that it is lossy. Okay, all the vowels are not visible and it is lossy. So it depends on the application whether you can use it or not. So this is about text. You can use certain techniques for text compression in case of lossy. Next one is, if you want to reduce any image, in that case what will happen? You have to use JPG method. So in case of image, what we can do, suppose the image is something like this. We want, this is a circle, okay, and suppose we have represented it with 500 into 500 pixels. Okay, we have represented it like this. What we can do to compress it, we can decrease the resolution. Okay, we can represent the same image with much fewer pixels. So what we can do, if you'll reduce the resolution, the picture might be something like this. Okay, my art is not that good. Okay, it won't be visible, but something like this, the corners will be blurred. Okay, something like this, and now it is 80 cross 80 pixel. image. Okay, so what we can do, we can reduce the resolution, we can decrease the resolution, and we can compress the image. Fine, we can do like this. And in the JPG method, basically, which is used for compressing pictures or graphics, we are having certain phases. Okay, we are having certain steps. So what we can do in case of JPG, we are discussing JPG. Okay, suppose you are having one uncompressed picture. Okay, first of all, we have to perform picture processing. Now what is this picture processing? Your picture is divided into 8x8 pixel square blocks. Okay, to decrease number of calculation, what we are going to do, whatever picture you have taken, whatever image you have taken, that will be divided into 8x8 pixel square blocks. Okay, so picture processing, I'll write it down. Okay, I'll mention it over here. First, picture processing. So the picture will be divided into, picture is divided into 8x8 pixel square block. Okay, to reduce the calculation. The second step is that we need to transform it. So picture transformation, basically here compression occurs. So here you need to use some compression algorithm to reduce the picture. So picture transformation means you have to compress it, and for compressing, okay, picture transformation. So for compressing it, compressing any image, we use discrete cosine transformation. Okay, discrete cosine transformation is used. So see, in the first step in picture processing, we have already divided the picture into some number of blocks. Now here, each block will be represented by some value, some numeric value in case of picture transformation. Okay, third step is quantization. Now whatever, see, each block we have represented using some numeric values in the second step. Now the next step is quantization. In quantization, what we are going to do, that the values which we have determined in this step, in the second step, are quantized according to the specific properties like resolution or something like we discussed over here. So what we are doing, we are decreasing the resolution over here. So same way we are going to do it for this step also, that whatever value you have given to particular block, we are going to reduce it using some specific property, like you can take resolution also. Okay, so what you are going to do, that in case of quantization, okay, values are quantized. Which value is quantized? Each block, see, in the first one we have divided into square blocks. Now in the second one, we have given some numeric value to each block. In the third step, each value which is given in the block numeric value will be quantized. So element near to 0 will be converted to 0. In order to reduce size, all the quantized value will be rounded to integers. You may have minus values, you may have positive values. So all the values will be rounded to integers. Okay, it can be negative also, but it will be rounded to integers. Now in the fourth step says that you have to perform encoding. Okay, so basically when you have quantized the values of each block, now in the last step you have to provide a data streaming in form of bits or bytes in sequential way. Okay, basically picture will be represented by using encoding. Some bits will be there, some pattern will be there, and that will be used to represent it. So you can use anything, like in this case I gave the example of resolution, so you can reduce the resolution in order to reduce the size. Fine. So this is the case of image. The next case is if you want to reduce audio. Okay, for audio also we are having so many methods. Suppose we are using one of the method which we use is perceptual encoding. So in case of perceptual encoding, we compress the audio. See, audio compression is basically used to compress speech or music. Okay, so the method which we are discussing is perceptual encoding method for audio compression. So we can do it by removing information not perceived by most people. So we remove the data or information which is not perceived by most people. Okay, it is basically used by satellite radio. So you can write it down. This also used by satellite radio. See, what is the idea behind this? The idea is that some sounds can mask other sounds. Okay, like suppose I'm speaking here. Now, when I'm speaking, if someone start beating over here, okay, like I'm speaking and somebody starts doing this, tuck, 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 some noise like this. Now, what will happen? That my voice, that sound which the sound which I'm creating, okay, that sound will be masked by this sound. Fine. So what we can do over here, that we can remove that sound. Like we can remove my sound which is now masked by this sound. Okay, because only this will be heard by everyone. My sound won't be heard. So we can do it like this. Now one of the example is like suppose you are broadcasting a live flute concert and suddenly someone starts striking hammer on metal sheet like I did on this table. Okay, so what will happen, that if someone starts striking hammer, then you won't be able to hear flute anymore. So what is happening, basically the flute sound is now masked by hammer. So that is known as frequency masking. So what is happening over here, the ability of loud sound in one frequency band will be hidden. Okay, so what will happen, that here frequency masking is done. What is frequency masking? That if there is one sound and that is masked by another sound, okay, another louder sound. So there is one sound and it is masked by another louder sound, then that is known as frequency masking, and the softer sound can be removed. That is the purpose of perceptual encoding. What we are doing, that we are removing data which is not perceived by most people. So most people won't be able to hear the sound which is produced by me. Okay, whatever I am speaking, if someone will start doing another sound which is louder than my sound, then what will happen? You won't be able to hear my sound. So what I can do to reduce the size, I can remove the sound produced by me. So that part can be completely removed, because anyway, in any way, no one is able to hear it because some other louder sound is there. So it's better to remove it. So that's what we are doing in case of perceptual encoding. So by using this technique, you can perform audio compression. So these are the basic techniques which you can use for lossy data compression. So you must have seen that in every case, like in this case, also some data was lost because we have removed all the vowels from this text. That's why some data is lost. In case of this image also, we have decreased the resolution, but then also some you can see that some blurriness will be there on the edges. In case of audio also, some because we have created some louder sound and my sound was not visible, so not audible. That's why we have removed that particular sound. Okay, so that's what we did over here in case of audio compression. So now I think you must have understood. Your MPG also, your video compression also use the same method of JPG. Okay, in video you are having particular frames. Video consists of number of frames. There also in every frame you can use this technique of JPG. The same thing can be used. So these are the basic techniques which are used, and all these techniques come under lossy data compression. So I hope you must have understood. In case of any confusion, you can ask it in the comment box. Thank you so much.